Let's do it again. So first plan of attack is usually to change everything into sines and cosines. Use the fact that tangent is sine over cosine. Grab a common denominator to smush all this stuff together. So if I multiply, or maybe just multiply the whole thing by cosine x, so that'll give me sine x cosine x minus cosine squared x minus sine x equals minus cosine x. That's lovely. Right. And then, what can we do from there? What if I were to kick this cosine over, set it equal to 0? Usually it's a good idea if I have powers greater than 1 to set it equal to 0, and cross my fingers that this thing is going to factor for me. So kicked them over there, and I've got 4 terms, so maybe it'll group. So if I took these two and factored out a cosine x, I would be left with sine x minus cosine x. And if I were left to this guy, I could take out just a minus 1, and I'd be left with sine x minus cosine x. And thank goodness the problem was rigged. They match. It'll factor out. So I'll have cosine x minus 1 times sine x minus cosine x equals 0. Ha-ha! So now either this equals 0 or this equals 0 by our zero product property. So either the cosine of x will equal 1 or the sine of x will equal the cosine of x. So thinking to our unit circle, what angle gives me a cosine value of 1? What angle gives me an x value of 1? Well, that's 0 and just 0. And then, this one here, where the sine equals the cosine, you could either think of it, what unit circle value does the sine equal the cosine? You could also think of, if you divide by cosine, where's the tangent equal to 1, and that will happen at your lovely pi force angles. It's my favorite angle ever, pi force and 5 pi force. So if we were just going once around the unit circle, just listing answers from 0 to 2 pi, we'd be done. But what if they said list all of them, right? There are an infinite number of angles that will make this thing true. You can keep looping around the circle as many times as you'd like. So if I want to describe this 0, I could just add 2 pi as many times as I wanted. So 2 pi k, 0 plus 2 pi k for that one. And these guys, what happens with tangents is that pi force and 5 pi force end up being pi apart, 180 apart. So instead of taking the pi force and adding a full 2 pi k, and then also taking the 5 pi force and adding a full 2 pi k a bunch of times, it's true, but you've double counted a bunch of things. So instead, let's make it more compact and just take this pi force and add pi as many times as we want. So we'll take pi force plus pi as many times as we like, and there we have it.